Okay, this is a parallel circuit, and you notice that immediately there's multiple paths, and so we have two coming off of here and two going there. And if you look at there's almost like two series circuits put together side by side, and so these are parallel because they're parallel to each other. And the drawing is like this, where we have a battery and there are two lines, multiple paths. Now, since they're both going directly to the battery, that means that in this case, with series, the amps are the same, but with parallel, the volts are the same. So this column with the volts is going to be the same amount of volts for each one, and the same as the total. So we can actually start off by checking that. Real simply, I'm going to change this to 2 DC volts. The battery should supply about 1.5 volts. And I can check on this side of the battery and on this side of the battery as well. And I get about 1.47 as the total. And I'll write that down, 1.47 volts. And then if I check specifically at each resistor, I should find that it's approximately the same. It might not be exactly the same, but we're looking for 1.47. And so that's about 1.46. And I'm going to call that one the brown one. Yep. And just so you know, I could tell which ones they are, but just so you know which ones they are. 1.46, that's just a helpful hint if you're having trouble figuring out which one they are to write the actual color. 1.46, and then again here we have 1.47. So there's going to be a little bit of error just due to nature. Okay, so that does a good job of showing you that these are all the same, relatively the same. And then we're going to do the same thing, use the same type of technique to measure resistance, but when we measure resistance we have to disconnect the volts. So I'm measuring the same way, and I don't want the battery connected, so I'm disconnecting the battery, and then I'm changing my multimeter to 2000, and so in this case I get 219, and that was the same as before with the series circuit that we had done. So that is the turquoise one, and that is about 219 ohms, and that's the turquoise one. And then we do the same thing. I can go ahead and reconnect this if I want to, and then I'm going to disconnect this one. So I'm disconnecting the electricity before I measure it, and I get about 32 ohms, 31.8, 31.7 ohms. Okay. Now, I said 31.8, I think. Okay. So these will not add up. They'll add up in a different way. They'll add up in an inverse relationship, which is shown here, 1 over R1 plus 1 over R2. So I could show you that in my calculator, but before I do that, I'm going to disconnect the electricity of both of them now. And then I'm going to measure the ohms across both of them simultaneously, like this. So I have both resistors now, and I get about 27.7. So this is going to be less than either one of these. So this is 31, which is the smaller one, and so that is less than either one of those. My light just fell. And so if I was to measure that on my calculator, I would find that I would do 1 over, or if this has an inverse button, it's actually a little bit easier even, if I can find my inverse button, which right offhand I can't. I'm sure it's on there somewhere, but I'll find it later. So what we have here is, I gotta turn back on. Where's the on button? Can't find the on button. Okay, so 1 over, parentheses, 1 over 219 plus 1 over 31.8 and parentheses equals, and I get 27.76, which is really close to that. I just did data calculation right there. Okay, now if I didn't want to measure current, I could just do it mathematically and find out what the current is for those. The first one I should get is with the turquoise one would be 1.47 divided by the ohms of that resistor, 219, should give me about, and this is scientific notation, so it should give me about 0.0067. So I'm looking for 0.0067 when I do this next test. So I'm going to put this back together how I had it, and I'm just going to test the turquoise one. So in order to test the turquoise one, I'll show you how to set this up first. I'm going to put it on milliamps, and then I'm going to change this to DC amps. That's set to 2 milliamps, and I'm going to now do the turquoise one. I'm going to disconnect one side and connect it where it was disconnected, and then I'll reconnect it on the other side. And so all the amps will go through this. So let's see. It's giving me a very small number. Oh, I must have the electricity going. I disconnected electricity because I was doing the resistance. So I need to reconnect the electricity there, obviously, to get a number. And I'm getting what I said before, pretty close. 0.0064 with that one. And of course, nothing's going to be exact, 2 zeros actually, 0.0064, because you have heat and your efficiency is 100%, etc. and so forth. It's not going to be exact. It's precise enough though. 0.0064 and 0.0067 are relatively close to what we expected. And then the other one is a different path entirely, and it has the same amount of volts, but it has less resistance, so we're expecting a higher number. With less resistance, we expect more current to flow through that one. So we do the same thing. I'm going to connect it here to see how much is going through this one, and I get even more. Is the electricity not connected here? Electricity should be connected. I should be getting a reading here, and I am not getting a reading, so I'm wiggling my wires to make sure that everything is good to go. And I'm not getting anything. Oh, there it goes. I must have okay. It's not giving me a good reading at all. What was that? Okay, I think I'm going to have to troubleshoot this one, and that's a bummer. Find out what went wrong. Oh, there we go. Okay, so we have 0.042, we'll call it. 0.042. And so that is much higher because I have a much smaller resistance. Now if I add these two together, I should get the total resistance, or excuse me, the total current. And the total current would be something around 0.048. So if you add those two together. So what I'm going to do now is I'm going to disconnect it, and I'm going to show you how to get the total resistance. Excuse me, I said it again, the total current. So I'm going to disconnect both of these now, and I'm going to connect both of these to here. And this number should be, once again, an addition of all of them together. And so I have 0.047. So that's pretty close to what I predicted, 0.047, which is pretty much the addition of these two to make that. So in a parallel circuit, what you're going to see is you're going to see the volts are the same, that these add up to the total. This current plus this current equals your total current. That this is the one that has the most resistance, so it's the smallest current. This one, the total, has the least resistance, so it has the greatest current. This plus that equals that. And then finally, the resistance adds up in this funny equation right here. So once again, Ohm's law works this way. Same. This adds by that funny way, and that is a parallel circuit. And once again, we are done and happy. Have a good day.